Good afternoon, students. Today in this video I will discuss about some non-ferrous alloys. We have already discussed about many non-ferrous alloys. In non-ferrous alloys, the base metal is not iron, any other metal than iron. And many of these alloys are costly. So now we will discuss about certain alloys which can replace these non-ferrous alloy. One is high alloy materials like stainless steel grades of duplex, super duplex materials. So what is this? Duplex stainless steel. So duplex stainless steels are called duplex because they have two phases. One is austenite phase and the other is ferrite phase. In iron carbon diagram already we have discussed about these phases. So austenite phase is of face-centered cubic lattice structure and ferrite has body-centered cubic lattice structure. So these austenite and ferrite exist in duplex stainless steel in equal proportions. So this is the composition of duplex stainless steel. This is high alloy steel because other than carbon, the other alloying element exists in high proportion. Chromium is up to 20 to 28%, molybdenum up to 5%, nickel up to 9%, nitrogen is 0.05 to 0.5 and rest is iron. So the properties, the major property is corrosion resistance. So this has a property of corrosion resistance, particularly chloride pitting corrosion. So this property is highly required to deal with any chloride forming atmosphere because it has high corrosion resistance towards chloride pitting corrosion. Another property is higher strength than any other standard austenitic stainless steel. So the uses are in offshore oil and gas industry for pipe work systems, manifolds, risers because of corrosion resistance. In offshore areas, corrosion is the major factor which is to be considered during selection of the material. Because of this corrosion resistance of duplex stainless steel, it is used in these areas, and this steel is also used in petrochemical industry in the form of pipelines and pressure vessels. Due to less percentage of expensive nickel, life cycle cost of duplex stainless steel is lowest in many applications. Here we have used a high percentage of nickel, less percentage of nickel. And as nickel is very expensive, because of its less percentage, the cost of the material is lower compared to other material which can give service in these areas. That is why the life cycle cost for these applications will be reduced if we will use duplex stainless steel. So once again I am summarizing, this duplex stainless steel material is composed of high alloy material of steel. Because the percentage of other alloying element is higher, it is known as high alloy stainless steel. So duplex steel has two major properties. One is corrosion resistance and another is high strength. And one advantage, it contains less percentage of nickel. So because of the cost of nickel, as it uses less percentage of nickel, its cost will be less compared to other material which can render the service in these applications. Another high alloy steel material is super duplex stainless steel. So composition is chromium 25%, molybdenum 3.7%, nickel 7%, nitrogen 0.2%, other is iron. So depending on the composition, the percentage of alloying element, this material is divided into duplex stainless steel and super duplex stainless steel. So what is the properties of super duplex stainless steel? Higher pitting and stress corrosion resistance in chloride environment than duplex stainless steel. We have already discussed duplex stainless steel has corrosion resistance in chloride environment. Pitting resistance is there, but in case of super duplex stainless steel, these properties are even higher. So where this corrosion is of high degree, to avoid high degree of corrosion, one will choose super duplex stainless steel instead of duplex stainless steel, because this corrosion resistance property in chloride environment for super duplex material is higher than the duplex stainless steel. Pitting resistance of super duplex stainless steel is equivalent or greater than 40. Other properties are high strength, high thermal conductivity, low coefficient of thermal expansion, good workability and weldability. So it is used in heat exchanger for tubes and pipes of heat exchanger to handle gas and oil. So it is used for heat exchangers as well as for pipes to handle gas and oil. Pipes in various industries which are to handle chloride, mechanical and structural components, utility and industrial systems, rotors, fans, shafts, press rolls, where the high corrosion fatigue strength is required. So these two are high alloy material. So next we will discuss about low alloy material. Alloying element, percentage of alloying element is comparatively low. One is P91. P91 is highly used in thermal power plants. So its composition is chromium 9%, molybdenum 1%, other is iron and carbon, and very small amount of manganese, phosphorus, silicon, sulfur. In power plant service, in superheater coils, steam pipings and headers, this alloy is used. Properties: P91 is a type of creep resistant strength enhanced ferritic alloy, which are steels designed to retain strength at extremely high temperature. So this is the specific property of P91. We have already discussed high alloy material, that is super duplex stainless steel and duplex stainless steel. The significant property in that case is corrosion resistance in chloride atmosphere. Here the major property is higher amount of strength at extremely high temperature. Because of this property, it is used in thermal power plants. Because in thermal power plants we have to handle very high temperature, particularly in superheater coils and steam piping and headers. Another low alloy material is P22. P91 and P22 are low alloy materials because of the alloying element is added in less percentage. Chromium here is 2 to 4%, molybdenum 1%, other is iron, carbon, manganese, phosphorus, sulfur and silicon. So P91, P22 is varying percentage of alloying elements, chromium, molybdenum. So the properties are high temperature strengths. This is the major property for which these materials are used in thermal power plant. High oxidation resistance, high tensile and yield strength. Chromium increases the hardness and strength and minimally reduces elasticity. Molybdenum increases high temperature creep strength and corrosion resistance. So basically chromium and molybdenum is added along with iron, carbon and very small amount of other alloying elements such as manganese, phosphorus, sulfur, silicon are added to prepare these low alloy materials. And it has a significant property, that is strength at very high temperature, for which these are used in power plants, refineries, petrochemical plants and oil field service where fluids and gases are transported at extremely high temperature and pressure. So these are some high alloy and low alloy elements which are specifically used for a particular service. That is why these materials are significant from engineering point of view. The high alloy element, super duplex stainless steel or duplex stainless steel, is used in chloride environment because of its corrosion resistance property. Similarly, low alloy material P22 and P91 are used for their strength at very high temperature. These materials are used in thermal power plants, refineries, all service conditions where we have to transport at very high temperature and pressure.